Welcome to the Intel Network Builders Technology V Summit series. It's time now for our session on how ORAN innovation continues to lead the way for network transformation at the edge, part of the 5G RAN V Summit. The radio access network is undergoing a profound change in the way that operators can interconnect components from different vendors through standardized interfaces. This Open RAN model promises significant potential and opportunities for network operators. But what is the technology behind Open RAN? What are the architectural benefits? And what adoption are we seeing across the world? Well, to tell us more, I would like to welcome Udayan Mukherjee, Chief Technologist for Network Infrastructure, Network Platforms Group at Intel, and Sachin Katti, Co-Chair of the ORAN Alliance TSG, Professor at Stanford University and also Advisor for Vmware. Hello both of you, and thanks very much for joining us on the session today. As I said, we're going to look at the technology that underpins Open RAN and how this leads to new opportunities for network operators. But before we do, I'd like to ask you both about why the industry is now paying so much attention to Open RAN. Uday, can you explain what is Open RAN and what's the problem with the current radio access networks?
Yeah, thank you, Guy. And hi, Sachin. This journey for this disaggregated and virtualized RAN began, a decade back. I mean, there was a seminal paper on cloud RAN. I think that came around 2010 or 11. But for a while, this platform was closed. So you go to a same vendor for the base station, the DU, RU, CU, everything together. And it was not virtualized. So you cannot get the pooling effect. So what happened? We started working on it. But a few years back, ORAN Alliance actually brought in a lot of like-minded people, companies that actually say, hey, you were working on the virtualization. What about interoperability? What about creating interoperable interfaces between the platforms? And that's what that ORAN brought in a lot of companies, like-minded companies, AT&T, China Mobile, Vmware, Intel from day one. And with that goal of actually, working on those, disaggregated interfaces, the standard interfaces. And actually, Sachin was here. He was actually associated with us from day one. He's a TSC chair here on ORAN. So, Sachin, you can add more into this.
Thank you, Udayan, and nice to meet you again, Guy. So as Udayan mentioned, this is a journey that we've been on for the last few years. And just to give some history to the audience, ORAN is around 2.5 years old, but in fact, predating ORAN was a forum called XRAN that we had set out of Stanford. And I was doing research at Stanford on how do you disaggregate the radio network. So it's been a journey for the last few years, and it's really picking up momentum right now. And the reasons for why that is happening is, I think, the trend everywhere about how do you bring data center economics and cloud agility to every part of the network. So the telecom operators have gone through that journey for the core network, right? So the packet core is virtualized, is containerized. And the natural progression of that journey is, and how do you bring the same kind of economics, same kind of agility that the cloud has delivered everywhere else to the radio access network. So that's one aspect. The second aspect that ORAN is really focused on is breaking apart the architecture and modularizing the components with open interfaces such that it's easy to introduce new innovation into this architecture. It had been historically very challenging for new entrants to come in and introduce one new piece of technology and make it work with everything else. And so really disaggregating and opening it up such that we unlock innovation from startups and new companies that are trying to get into this space. So all of this, which is kind of great news for the operators. They get cloud economics, they get the agility and operational efficiencies of the cloud, and they unlock new innovation from new players in this ecosystem. So that's why we see it picking up a lot of momentum over the last few years. And I think we are in for a great ride over the next few years.
Thank you both. Well, let's go through the technology that addresses this market opportunity, should we? Uday, why don't you start with taking a look at where we are today in today's RAN?
Yeah, actually, if you look into it, ORAN, as I was alluding to at the beginning, is the base station systems, or if you look into this, the radio access network itself consists of a couple of things. The first and foremost is the base station, the radio unit, the distributed unit where you do the layer 1 processing, the control unit, the CU we call it. This is, which is basically is a closed system to begin with. I mean, say for example, an operator like a Verizon or AT&T wants to implement a 5G, network. So what do you have to do? You have to go to one system vendor, and he'll provide you lock, stock, barrel, the everything. Whether it's a radio unit, the actual radios, the distributed unit, whether it's the base station, the BBU that we call it, as well as the control unit, the elements that controls everything. Okay, so it's one neck to choke, that works. But some of the things that actually Sachin talked about limits innovation. It limits participation by other companies, and at the most, I mean, these are proprietary, dedicated hardware. So essentially, the economics of scope or scale, basically, that the operators are basically looking to us, and they look to us, Facebook, Google, and Amazon, say, wait a second. I mean, they are getting, huge amount of utilization, the economics of scope. Here, you don't get this scale here with this closed system, proprietary system from one vendor. And the things are, there's no chance for smaller companies to actually add technologies into it. So essentially closed systems. It worked in LTE, it worked even in 3G. But as we move in 5G, there are so many other vectors are coming, especially as the cloud native aspects of elements like virtualization, disaggregation, the elements that actually improves the scaling part of it. So that is missing there. So that's what the current state of affair is, the guy in the RAN.
Thank you, Uday. So, Sachin, can you explain to us what the ORAN Alliance is proposing? What work is the ORAN Alliance doing to change all this?
Yeah, no. So as just picking up from where Udayan left off, so we have this, I like to call it a gray world of everything closed and vertically integrated. And fundamentally, what ORAN is trying to do is really go to a more open world. I like to joke on this particular picture that you're seeing here that we're going from this gray, cloudy skies to a rainbow-colored, multicolored world here on the right. And that's really where ORAN is trying to get to. But jokes aside, what's really going on here is to really deconstruct that gray box into a few different components and make sure that all of those components are talking to each other using open interfaces. And if there's any software components, that the software components are running on off-the-shelf hardware on cloud stacks rather than running very tightly coupled with the hardware, which makes them very brittle and hard to change, right? So to kind of walk through this in a little bit more carefully, there's kind of 4 levels of disaggregation happening that ORAN is trying to bring to the table. So the first 2 are radio and compute disaggregation. And in a nutshell, the audience can think of this as, how do I disaggregate hardware in the radio network, right? So the radio disaggregation refers to having a radio hardware that you typically would see on the top of cell towers coming from a variety of new vendors with open interfaces to talk to the rest of the system. And so the operator no longer is forced to buy the radio hardware from the same vendor that is supplying the rest of the radio software stack, right? So that's one. The second one, which is where Intel and Udayan himself personally has had a big role to play, is on compute disaggregation, which is using off-the-shelf compute like x86 from Intel architectures, and virtualize them or cloudify them, and then be able to run the radio software on top as general purpose software on this. Is the compute disaggregation. So you are able to take advantage of the tremendous improvements in silicon that have happened over the last 20 years and get data center scale and economics to the radio world. And then the last 2 pieces are more about decoupling the intelligence from the radio network and make it accessible via open APIs, such that new startups can come in and put in their own innovation without having to worry about designing the rest of the system. Right? And so that's about disaggregating the control plane and the management plane, really the brains of the radio access network, and make sure that the brain can interface with the underlying infrastructure with open, interoperable interfaces. And I deliberately ordered it in this manner because what we see happening is that operators are already adopting the radio and compute disaggregation. It's relatively mature. And we are seeing a lot of innovation now happening in the last two phases, the control and the management plane disaggregation. And I expect a lot of that will start to percolate into the field, into commercial deployments in the next couple of years.
So can you explain a little bit more about what you've come up with? Can you go into a bit more detail as to what exactly constitutes ORAN's disaggregated architecture?
Sure. And so I think maybe let's just pick on these points one by one, right? So on the disaggregated architecture, the first thing is this radio unit. So that's the, as I was saying, the hardware that typically sits in a cell tower or in a cabinet at the bottom of a cell tower. It sounds trivial. It often sounds very mucky, but it is actually a critical part of the network. So nearly 50% of the CapEx spend of an operator in the radio network goes in this radio hardware, right? And so just to put some numbers, RAN market around the world is between $30 to $50 billion a year in terms of CapEx, right? So this is really giant markets. So for a long time, it was that the hardware that you'd put at the cell tower, you had to buy it from the same vendor that was supplying you the base station software. Right? And so the first thing that ORAN focused on was the open front-haul interface shown in this architectural diagram here. And that really made it such that the ORU, this is the radio hardware, can be designed independently of the ODU and the rest of the software stack, so which is the radio software stack. So that's the most important interface on that front. The second piece is in this picture, you'll see the O cloud. And so that's really saying, how do I bring a cloud to extend my cloud, the telco cloud, all the way to the radio network and run all of these RAN software elements as pieces of as containers or virtual machines on top of it. Right? So that's a cloud reference architecture. And then you'll see an alphabet soup of interfaces. I won't go into the details of each one of these, but essentially, these are interfaces that are being specified such that we can tease apart the software that is running a radio access network into more modular components, such that they can be brought from different vendors, and an operator can stitch together a best of breed network. And the two I'll highlight are E2 and O1 and O2, right? So the E2 interface here, you might see it between the CU and the DU and the near real-time RAN intelligent controller. This is really kind of trying to do what SDN did for wired networks, right? So SDN was all about decoupling the control plane from the data plane for wired networks, and it has had a tremendous influence on the networking industry. So how do we bring a similar philosophy to the radio access network? And so the E2 interface is kind of the analog of the open flow interface, which is how do I decouple the control plane intelligence from the underlying radio access network? And then the O1 and O2 interface are about management, right? So today, again, if an operator deploys a radio network, buys base stations from a particular vendor, they actually have to buy a full management system from the same vendor, and that management system is only going to work for that vendor's infrastructure. So if I am an operator and I have 3 or 4 different radio vendors, I have to deploy 3 or 4 different management systems, essentially creating silos in my network operations. So the O1 and O2 interfaces are, how do we really build, trying to enable the building of a multi-vendor management system that sits on top and really gives operational scale for operators as they go towards 5G. So those are kind of the few details that I'd like to highlight, and I'd really encourage the listeners to go look at ORAN Alliance. There's a lot of great material now coming out that is going into quite a bit more detail on all of this.
Thank you very much, Sachin, for that very, very clear overview of where we're moving the RAN architecture. Uday, where do you see ORAN gaining the most traction? Are we talking specific geographies or deployment scenarios?
Actually, this is this whole disaggregation and the virtualization aspects of it was happening even before ORAN, as Sachin says, 2.5 years old, but that movement started before that. So actually, there are already proof points. The Rakuten announcement that they went live in, I think, April, with 1 million plus subscriber now, is actually completely virtualized network. And actually, in the next generation, is going to confirm to the interfaces that ORAN is defining. Verizon has already announced, the work that they're doing with Intel and Samsung. The Dish that's already announced that they're working with Vmware and Intel. And so there are all these actual commercial trials and deployments going on with already bringing in the flavors of ORAN specification and interfaces. And I'll tell you, Plug, one other thing, Guy, that Intel has been investing quite heavily on the software as well as the innovation on the silicon hardware platform. So the first Plugfest that ORAN did in December of last year, for all these COVID things, screwed us up, is essentially based on open platform and version of what we call it FlexTran software, which actually incorporate all of the interfaces that Sachin talked about in the ORAN. So a lot of progress, and it's only going to get further steam in the next few years.
Yeah, indeed, and we have more coverage of FlexRAN in this V Summit. Sachin, there's increasing interest in the ORAN Alliance as well, and it has a comprehensive release schedule already in motion. But who's actually leading and collaborating in this community?
It's now a global community, right? So pretty much every player in the ecosystem is now a part of the ORAN Alliance, and it really is a collaboration between operators and vendors and even academic institutions, of which I'm a member, right? So we are seeing a tremendous amount of progress and collaboration coming, especially from both the big vendors who have been more established, but also new entrants that we are seeing. For example, Udayan referred to Rakuten and Dish, which are all experimenting with new radio suppliers here. And deploying a at-scale network on top. So everyone is contributing to this, and because I think the tea leaves are clear, right? So I think it's very loud and clear what the operators want, and they're the customers. The message is that we want cloud, we want disaggregation, we want programmability as we roll out 5G in the radio network. And we really want to change the economics of how the RAN is rolled out and operated and managed. And so I think that has really given big impetus to the whole ecosystem to come together. And really what the job ORAN did was that 2.5 years back, we recognized that we needed to consolidate all of the different efforts that were happening around RAN disaggregation and have one global body that would be the body where some people would come and work on this. And that's essentially what ORAN Alliance has ended up being.
Well, let me ask you both this next one. What's next? What developments should we look out for in the coming year? Uday, let me start with you. What should the industry be focused on now?
Yeah, Guy, thank you. So as Sachin and I was discussing, so we have come a long way. We have the interface specifications for different layers that Sachin talked about, and we did a first Plugfest. But we have you have a lot more things to do. For example, in this year, security will be a huge focus for us. We want to make sure we are disaggregating the RAN network. We are actually virtualizing it, but we want to make sure that the security aspects are all taken care of. It's already being addressed, but we will do it formally, and which is what is happening in ORAN as we speak. I just imagine where we are there before and where we come. Right now, all the examples we talked about, Verizon, Dish, Rakuten, they are essentially buying radio from different vendors, the hardware from different vendors, the virtualized software from another vendors, And the whole thing is being orchestrated and managed by possibly a different vendor. So they're already getting there, a lot of plug and play going on. But what we have to do future is actually do more plug fest, do more interoperability testings, so that we make sure that these pieces work fine, integrated together, bring in a lot more ecosystem players to participate in this journey, and make sure you constantly address the KPIs, the performance per watt, the optimizations, reduce the OPEX and CAPEX for operators, all the business aspects of it, along with, do more interoperability testing, more plug fest. Those are all on the cards in the next couple of years.
Great. And Sachin, where do you see work accelerating in this coming year?
Yeah, I think apart from all the points, great points that Udayan made, I'll add a few more. So one is around how do we make ORAN-based architectures scalable for urban high-capacity deployments that need to use things like massive MIMO, right? So that's something that we hear a lot of noise in the ecosystem that ORAN may not be ready for those kinds of deployments. So I think there's going to be tremendous innovation happening over the next couple of years on that front. Second is really kind of figuring out what are upgrade paths. So not every operator is a Dish or a Rakuten who have a clean slate to start from. They have large existing infrastructure that is not open, that is not ORAN compliant, right? So, and the large investments that especially LT is going to continue to be around for a long time, almost acting as an anchor for adding 5G. So how do we build upgrade paths that gracefully let operators upgrade from 4G from a non-open 4G to an open ORAN compliant 5G? And so there, I think ORAN Alliance is putting significant energy in building those paths. And the last piece that Udayan mentioned is really we have focused a lot on building an ecosystem of new network software and equipment vendor suppliers. I think the attention also is now beginning to focus on what are the integrators here, right? So how do we make sure that all of these pieces come together in a manner that a tier one operator can deploy at scale and trust that it will work? So doing the interoperability testing, setting kind of open ways of making sure all of these things can come together and not expect every operator to have to do it again and again and again, right? So I'd say performance in terms of high spectral efficiency, that's the first piece. The second one is really the brownfield upgrade paths. And the last one is hardening this whole disaggregated ecosystem such that operators can get the benefits of disaggregation, but still enjoy the benefits of integration.
And finally, Udayan, how is the collaboration between Intel and VMware progressing?
Oh, yeah. So we have been working closely, and we have already announced the partnership with VMware and Intel. But even before that, these two companies are working closely in getting, making sure this vision of this virtualized RAN, this disaggregated and programmable RAN, comes to fruition. Things like our platform, the FlexRAN platform that we're going to discuss further in another session, working in a very, optimized way with the infrastructure, the virtualized infrastructure that VMware brings in, the lot of technologies behind that, the Photon RT, the real-time OS, the whole telco infrastructure, the cloud, the ESXi environment, to make life easy for operators or the deployers to actually deploy the systems. What good is a system is if it is very difficult to deploy or manage or run. So that's where both of our companies, technologies are coming into play. And we have been working closely here. We are creating joint labs and optimizing the systems. So a lot of exciting things happening between VMware and Intel jointly.
Good to hear. Well, we can't overstate the significance and impact of Open RAN on the telecoms industry. For now, Udayan and Sachin, thank you both very much for taking part in this session and introducing the 5G RAN V Summit. And don't forget to watch our next sessions in the 5G RAN V Summit. We have a session on enabling Open RAN deployments with FlexRAN, and also one on how to build an Open RAN DU with Intel's FlexRAN. For now though, thanks for watching and goodbye.